Welcome to solverfy, the place where learning becomes simple. If you're struggling with homework, assignment, or doubt in subjects, don't worry, you are in the right place.
In this problem, we want to determine the magnitude of force which must be applied to the end of a cord in order to raise a hook with constant speed. So from our problem, since the speed is constant, we know dv dt must equal to 0. Now, the height at which the hook is above the ground, y, is equal to the speed times the time that has elapsed, t. So y is equal to v times t. Now, the mass mi is equal to the mass per unit length of the chain and the hook times the distance y. So the mass per unit length times the length, my, and this is simply mvt. And so the rate at which the mass is changing, dmi dt, is simply m times v. Now that we have these expressions, we can use our flow equation and take the upward direction as positive. The flow equation tells us that the sum of all the forces acting on the chain must equal to m dv dt plus v di dmi dt. So the forces acting on the chain are due to the force of the cord, which is F, minus the weight of the chain, which is its mass per unit length times g times y. So it's mg vt. And this must equal to m dv dt, which is 0, since dv dt is 0, plus v into mv. So if we rearrange this equation, we can find the force that needs to be applied on the cord. And the force F is m into g v t plus v squared. And these values are known, so we can substitute them in and get the force as a function of time. So that's 2. The mass of the chain is 2 kg into 9.81, which is g into 0.4 times t plus 0.4 squared. And so we get the force that needs to be applied on the cord as a function of time is 7.85 t plus 0.32 newtons.